Okay, hopefully I haven't built this up too much, saying that adding and subtracting is harder than multiplying and dividing, but I'm totally confident you can all do this and do it well. So yes, our learning intentions will be adding and subtracting more complex fractions, and adding and subtracting with algebraic denominators. So this is, I think, a new step for a lot of you, but hopefully if you're confident with your factorizing and stuff like that, this will be quite okay. The questions that are set here as part of your pre-learning, when I'm looking at your textbook, and I'm looking at it right now actually, I think that if you do, for all of these, if you do the left-hand column and the bottom row, that should be plenty, okay? As long as you're confident with it at that point, but that's heaps of pre-learning, okay? The idea is, of course, that you get your pre-learning done like that, and then when you get into class, we can have a look at some of the really difficult questions, okay? So like questions 10, 11, 12, and 13. The other thing is, if you're really not sure, have a look at questions 1, 2, and 3. But I think most of you can skip that and get straight in to question 4. Key ideas, probably should have read this before, but add and subtract fractions by firstly finding the lowest common denominator. Okay, so that is making sure all our fractions are on the same base. So another way of looking at that is comparing apples to apples. Okay, so 1/3 and 1/2 aren't the same thing, but 1/3 is 2/6 and 1/2 is 3/6. So it does, if we got 6, we can just count how many we got and we can just add them together, okay? So throughout this exercise, you will be using the identity. You would have, as I said, you will use it many times in the past without realizing, but if starting to understand how these things work is taking you to the next level in mathematics. Okay, so you're also going to use the inverse. So we'll explain that in a minute, but actually I'll explain it right now. So the fact is, you know that when we're looking for that lowest common denominator, you know that anything divided by itself is equal to 1. It is its inverse, okay? So we use that all the time. That's how we get our lowest common denominators. So here's an example. A on B minus X on Y looks a lot like I did in the last exercise, doesn't it? So I'm going to focus on I'm going to focus on the other denominator, okay? So this has already got B in its denominator, but because of the Y here, okay, which I will rewrite as Y there, I'm going to multiply this by Y divided by Y, okay? And because this one here is B, I'm going to multiply this one by B on B. So I'm really just multiplying them by 1, aren't I? Okay, but because I'm the top and bottom by the same thing, but now I'm going to have both of the bottom have B on Y, B times Y, okay? By, and the top has YA minus BX, be excellent, okay? And so there you go, we've done that one. And I also remembered this minus sign. If it gets a little bit more complicated, like this, I might just move that over a touch. Might make my life a little bit easier. Actually, I didn't need to do that. So, but once again, if I've got this Y as blue, I'm going to multiply the opposite by Y on Y. Okay, that's multiplying by 1. We get the same base, and this B here is green, so I can multiply this by B on B. And so the trick here is, now I have to multiply Y by the whole. I've got my by here, so I have to multiply, and I'm going to make that even bigger, I just realized. So Y needs to multiply everything in the other expression, okay? And we have a plus sign here, and B times X minus 1. Okay, so that's all through there, and we have B and Y on the bottom. And this is the one I probably needed to extend a bit more. So let's put this one over here, because now we've got these fractions on the bottom. So let's make this one y minus 1. So if I go over here and do y minus 1 divided by y minus 1, then this is still 1. So anything times 1 hasn't changed. And if I can turn this b plus 1 into b plus 1 divided by b plus 1, okay, put a times there as well, then it's still divided, it's still multiplying by 1, nothing's changed, has it? So now I'm going to say, so I've got y minus 1 times b minus 1, b plus 1, so it doesn't matter which order I write them in, it's the same thing. When I say which order, long as everything in the brackets are correct, but it doesn't matter which bracket I write first. And so I'm going to say a times y minus 1, and I have a plus sign here, x times b plus 1. Okay, so hopefully it's not too complicated for you, me using these purely algebra symbols, but they're just to show you that this is exactly how we use our numbers, and what we're really doing here is, by making these bases the same, we're starting to compare apples with apples, because y minus 1, something divided by y minus 1 is not the same as being divided by b plus 1, but we've now got them on the same base. And to do that, this thing here, this b plus 1 divided by b plus 1 is equal to 1. Anything times 1 is itself. So we never changed anything, okay? It is 100% the same thing. We're just now putting it on the 1 base. This exercise, I am going to give you more. Let's spot the difference. This is a, can you see the error that our pretend student has made, okay? There's 2 equations. We'll do this in class, so don't worry if you haven't read it yet. Once again, there are videos for you to watch here if you want to see the textbook version of these examples, okay? I've written out my version of them. I think they'll be fairly similar to mine. I had to add these fractions together, so 4 and 2. Now, you can see earlier on I multiplied them by b and y, but that's because I don't know what they are. Here the lowest common denominator is 4, okay? Because I just have to make both bases the same. And 2 times 2 equals 4. Sometimes it's not exactly like that. So for example, you might have 8 and 6. And what do they both multiply? They both multiply into 24. So you might, whatever it works, numbers is not as straightforward as algebra in that way. But either way, we're going to make sure that both the bases are the same. And when we do that, we have to multiply one or both of these by a number that's on the top and bottom. Okay, so I've multiplied the 2 through, and here we go. Because we have the same base, 4 is this top expression can't be factored, so I can't simplify that any further. Okay, here we've got 2 different bases, so this is more like my examples I gave you at the start. All right, and how many more examples do I have? Just 2 more. Okay, and so now we're getting more complicated ones, but you should see we're just focused on the denominator. Okay, I put it here, might be more complicated, but always focus on the denominator. Okay, always focus on the denominator. You'll learn by the end of this year that I'm a terrible speller, which is terrible for a teacher, but it's true. All right, so like an English teacher who uses calculator all the time, I am a maths teacher who relies desperately upon that red line. All right, so these are more complicated at the top, but in the end they're still the same. Okay, but because we've got an actual example here, not just the algebra I had earlier on, I am going to expand these brackets and collect like terms. Okay, so I've made a point of letting you know that I'm going to do that there. And sometimes they can simplify down quite easily, but we're still left with just one term and a number here divided by another number. Now, I showed you early on at the start there that if you've got this type of thing at the start, I should make this a bit bigger. If you got this at the start, then doesn't matter that it's complicated here. 2 divided by 2 is a million divided by a million is equal to 4x divided by 4x, and it's equal to x minus 6 divided by x minus 6. It's all equal to 1, okay? Using the inverse idea. Multiplying by 1 using the identity idea, nothing changes, okay? So just because it's got that extra stuff on the bottom there, you're just going to multiply. So I'm thinking of, let me make this more obvious to people who read it a bit later, okay? So because it's the opposite side like that, that's why I was using that. Why doesn't it just highlight, please? Don't be annoying. I'm just going to highlight it green. So x minus 6. Okay, so that relates to that one. And this one over here, so I'm using the opposite base, okay, from this one. Because x plus 2 is here, I multiply the other side by x plus 2. And because the x minus 6 is on this base, I multiply the other side by x plus 2. Okay, and then, well, I've had to expand these brackets, and I ended up with 3x minus 2x is 1x, 6 plus 12 is 18, and I didn't bother to expand these brackets. I mean, you could if you want to, but it's really not necessary. Okay, the only time is sometimes they might be able to cancel across for some types of things. All right, so once I said, well, like I said at the start, hopefully that's all clear to you now, and you need to do this pre-learning left-hand column, right and bottom row for questions 4, 5, 6, 7, and 8. It's really important you get that pre-learning done so we get a chance to do some good stuff in class, okay? I know, and once again, I will see you in that class. Bye-bye.